Okay, class, now we're going to work on percentiles a little bit more. So we're going to look at how to convert z-scores to percentiles. Okay, you learned how to calculate z-scores in the last section. Turns out that each z-score represents a percentile. A percentile is a real simple idea. A percentile is what tells us where we rank, where a certain data point ranks up in comparison to the other data points. Like, so if I say we're in the 78th percentile, if a data point's in the 78th percentile, that means that it is better than 78% of those things, of those other data points. So let's take a look at a table here. So here's a table that tells you the different z-scores related to percentiles. So like if the z-score for a particular data point is 2.1, that means that the percentile is 98.21%. So if I have a data point, like let's say my score on a test is at 88%, then that means I'm in the 98th percentile. That means I've done better than 98% of the other people in the class. Okay, that's how we read a percentile, okay? And so we're going to use this table a lot. In fact, you're going to need this table for several of the homework questions. Okay, so let's mess around with some actual problems here and start to figure out how to get back and forth between z-scores and percentiles and how to calculate actual percentiles. Okay, let's work on this one. The distribution of monthly charges for a cell phone plans in the United States is approximately normal with a mean of 62 and a standard deviation of 18. What percentage of plans have charges that are less than 8360? Less than 8360. Okay, so we need to find out, first of all, what standard deviation is this? So let's work on that, because in order to figure this out, we got to find the standard deviation from the mean, and then we're going to use, we'll calculate the z, we already have the standard deviation, my bad. We need to find the z-score, and then once we have the z-score, we can use this table to work on this. So let's find the z-score. So the z-score at 8360 will be 8360 minus the mean, which is 62, okay, all over, divided by the standard deviation, which is 18, okay? If I plug that into my calculator, I get, drop my calculator, sorry. This would be 83.60 minus 62 divided by 18. Okay, so the standard deviation is 1.2 of this data point, 83.60. Okay, so I need to figure out the percentile now. So I'm going to bring up that table again. Okay, so if I go to my z-score now, which is 1.2, and I find it on here, okay, looks like 1.2 is right there. So it looks like the percentile is 88.49. So that means that 88.49% of plans are less than 8360 because this is in the 88.49 percentile. That means that 88.49% of the plans are below that amount. So that's the amount I'm looking for. Okay, let's try another one that's a little more complicated. The Easter egg, by the way, is 334567. That's 334567. Okay, so let's look at this one. Female adult heights, North America, are approximately normally distributed with a mean of 65 inches and a standard deviation of 3.5 inches. What percentage of North American women have heights that exceed 69.9 inches? So first of all, let's find the z-score for 69.9. Well, that would be 69.9 minus 65, which is the mean, all over 3.5, which is a standard deviation. Okay, pull out my calculator. 69.9 minus 65 divided by 3.5. It's 1.4. Okay, so what's the percentile? Okay, so 1.4 is right there. So the percentile is 91.92%. Okay, so that means that what percentage of North American, asking the question again, what percentage of North American women have heights that exceed this? Well, what this percentile means is that 91.92, if you are 69.9 inches, that means that 91.92 people, let me erase this for a minute, I'm going to make this a little more clear. That means that 91.92% have heights less than you, and then this is the percentage of people, 100 minus that, which is 8.08%, is the percentage of people that have heights greater than you if you have that height. You see how the percentile works? The percentile tells me how many people or how many data points are below that point. If I'm asked what percentage of we're going to have heights that exceed that, I've got to take 100 minus that figure. So it's a little different than the last one. Okay. Okay, let's take a look at this one now. A little bit different variation. The distribution for the life of refrigerators is approximately normal, with a mean of 14 years and standard deviation of 2.5. What percentage of refrigerators have lives between 11 and 18 years? Okay, this is not too bad. So we have two different data points we're looking at now, 11 and 18. So let's find the z-scores for each of those. Z at 11 would be 11 minus 14 over the standard deviation, which is 2.5. This is my mean here, 14, okay? So let's figure that out. 11 minus 14 divided by 2.5 is negative 1.2. That's a z-score there. And then let's look at z at 18. That would be 18 minus 14 over 2.5. That's 1.6. Okay, so here's the idea. Make a little table here. I've got 11 here as a data point. I've got 18 here as a data point. I'm going to put the z-score above it. The z-score for this one is 1.6, and the z-score for this one is negative 1.2, okay? Using my table, if I go back to my table, if I look at negative 1.2, that is, I'm trying to find it here. It's kind of hard to read and blurry. I'm sorry about that. That's right here. That corresponds to 11.51 percentile. Okay, so this corresponds to an 11.51 percentile. I don't need to write tile, but anyway, that's 11.51 percentile. And then this one, 1.6, corresponds to 94.52 percentile. And we want to find the percentage of refrigerators have lives between those two. So that means below 11 over here, 11.51% of the people have below 11 years of a life of a refrigerator. Okay. In between these, all I need to do, guys, is just take the 94.52% and subtract it from the 11.51%. Because I know a total of 94.52 are in this range, and I know that in this range is 11.51, so to find out the people in the middle range, I just subtract them. It's that simple. What do I get for that? 83.01% is your answer. Okay. A picture of this using the actual graph, the bell curve graph, or the normal distribution graph, is right here. Notice we had an item 1, which was my 11, and we had an item 2, which was my 18. They both had z-scores and then corresponding percentages. This was the percentage for 18, and this was the percentage for 11 that we just did. So the way I find the percentage between them is I just subtract the B minus the A right there. Okay? Okay, so here's a summary of everything we did using a table in the book. Really good table. The percentage of, looking at the first one here in red, the percentage of data items less than a given data item with Z equal to B. So if they give you just one data item and you're trying to find the percentage of data less than that, that was the first example we did. You just literally go to the Z score table and find the percentile that matches it. Okay. Then in green here, teal, second one, percentage of data items greater, you just take 100 minus, this is the one where we did 100 minus whatever the percentile we found was. Okay. And then in purple here for the third one, if you're looking at the percentage of data between two different items, then you would take the percentile here and the percentile that you find with that from the table and you subtract them. Okay, that should get you ready for this section. That's all we're going to cover today. Then we're actually not going to do 12.6, and we're going to go ahead, and I know I'm modifying a lot because I'm trying to get through some of the graph theory stuff. So just kind of follow what the syllabus or the homework assignments and the lectures are doing. So that should get you through 12.5.